Hello everyone, in this video we will discuss about the problems based on the eudiometry. The concepts of eudiometry we have discussed in the last video. So let's start with the first example. Air contains 20% oxygen by volume. Find the volume of air required to complete combustion of 50 ml of acetylene. So first at all we will write the balanced chemical equation of combustion of acetylene, which will be C2H2G plus O2G. This will give CO2G plus H2OL. So we can balance this reaction. 2 carbon, 2 carbon, 2 hydrogen. So the oxygen will be 5/2 oxygen. So definitely under identical condition, 1 volume of acetylene combines with the 5/2 volume of oxygen. So the volume of oxygen required for 50 volume or 50 ml of acetylene will be equal to 5/2 into 50, which will be equal to 125 ml, right? In this question, it is required to find the volume of air. Obviously, air is not combining with the acetylene directly. Oxygen is combining, so we can say that let's X ml of air is present. So 20% of X will be the volume of oxygen, that will be equal to 125 ml. So to calculate the value of X, we can solve this. This will give, on solving, X equal to 625 ml. This will be the volume of air required for the complete combustion of acetylene. In the next question, calculate the magnitude of volume change in ml if 30 ml of toluene C6H5CH3 is burnt with excess amount of oxygen. Obviously, excess amount of oxygen is given, so the toluene will completely consume. So definitely we can write the balanced chemical reaction for this. C6H5CH3G plus O2G. This will give CO2G plus H2OG, which is H2OG in vapor form or gaseous form. So definitely we can balance the carbon, 7 carbon, 6 and 1, and 8 hydrogen. So definitely 9 oxygen will be here. So we can say that at T equal to 0, initially 1 volume of toluene and 9 volume of oxygen combines. So it is given that 30 ml of toluene, 30 ml of toluene will combine with 270 ml of oxygen. Definitely at time T, there is no limiting reagent present in this reaction, so both of will completely consume. So with respect to toluene, we can calculate with respect to any reactant the amount of product. So 30 ml, with respect to 30 ml of toluene, the volume of CO2 will produce will be 210 volume, 210 ml, and volume of water vapor produced will be 120 ml. So definitely change in volume, that will be delta V, we can calculate as 30 plus 270 will be 300, and here 210 plus 120, this will give 330 minus 300, that will be equal to 30 ml. So this will be the volume change. Definitely the final volume is more than initial volume. So definitely there is a volume expansion is taking place. We can observe that the number of gaseous molecules which is forming in the product side is more than reactant side. We can say that delta Ng is greater than 0, where delta Ng stands for summation of moles of gaseous species in product minus gaseous species in reactant side. In the next question, it is given that 1 liter mixture of C3H8 and C2S6, propane and ethane is completely reacted with oxygen and 2.5 liter of CO2 is produced. It is required to find the composition of mixture when all volumes are measured under identical condition of pressure and temperature. So we can take this is C3H8 and C2H6. The complete volume of this mixture is 1 liter. Let's suppose A liter of C3H8 and B liter of C2H6 is present. So A plus B, we can write it is equal to 1 liter. This will be the equation 1. Now we will write the combustion reaction of propane and ethane separately. So we can write as C3H8 plus 5O2G, 5O2G, and this will give 3CO2G plus 4H2OL. We can write the combustion reaction for ethane also, which is C2H6G plus 7 by 2 O2G. This will give 2 CO2G plus 3 H2OL. So obviously by using the stoichiometry, we can say that if one volume of C3H8 combines with 5 volume of oxygen, 3 volume of CO2 is produced. So for A volume, 3A volume of CO2 is produced. In the same way, for 1 volume of C2H6, 2 volume of CO2 is produced. So for B volume, 2B moles, 2B volume of CO2 will be produced. And in the question, volume of CO2 is given. So the volume of CO2 which is produced in the both reaction will be 3A plus 2B, and this will be equal to 2.5 liter. This will be equation number 2. On solving equation 1 and equation 2 for A and B, we will get A is equals to 0.5 liter and B is equals to 0.5 liter. We can say that 50% of each propane and ethane will be present in the gaseous mixture. Let's take another application of the eudiometry in which we can find the formula of hydrocarbon by using the eudiometry concept. A 10 ml of alkane, we know that alkane, the general formula of alkane is CnH2n plus 2. On complete combustion gives 30 ml of CO2. Find the molecular formula of alkane. So obviously in this question only data which has been given for the CO2, which is 30 ml. So we will consider this equation as I told you the concept in the eudiometry. First we will write the equation for the one volume. So obviously one volume of hydrocarbon, this will be X plus Y by 4 volume of oxygen, and this will be X volume of CO2. And because in combustion, until or unless it is not mentioned the water in the vapor phase, we will consider it is in liquid phase. So volume of water we will not consider here. So this is the equation for one volume of hydrocarbon, one volume of hydrocarbon. Now we will write this equation for the given volume of hydrocarbon. So the given volume of hydrocarbon or alkane is 10 volume, 10 ml. So for the 10 volume, it will be 10. It will be X plus Y by 4 times. Sorry, this will be 10 times of this, and this will be 10 times of this. So obviously volume of CO2 produced as per the equation will be 10x, and this will be equal to 30 ml, which is the volume of CO2 given. So on solving you will get X equal to 3. And what is X? X is basically number of carbon, and the formula of alkane is to be calculated. So we can substitute the value of X as 3 in this equation, in this general formula, and we will get C3H8, the formula of alkane. Now we can take more examples on this, that 10 ml of hydrocarbon on complete combustion gives 30 ml of CO2. It is the same data as an earlier question, and additional data of oxygen, which is 40 ml of oxygen required, is also given. So we will follow the same pattern. We will write the equation for first it all 1 volume of hydrocarbon, and so for 10 ml or 10 volume of hydrocarbon we can write as it will be 10 ml. So this will be 10 bracket X plus Y by 4 volume, and this will be 10x volume, and definitely water is in the form of liquid, we will not consider this. So volume of CO2 will be equal to 10x, which is equal to 30 ml. So x again will be equal to 3. The additional data of oxygen reacted is also given, so we can put the volume of oxygen, that will be equal to 10 bracket x plus y by 4, and this will be equal to 40, as the volume of oxygen given as 40. And x, the value of x we can substitute here as 3. On solving for y, we will get y equal to 4. So the formula of hydrocarbon, that will be, we will get as C3H4, right? We can take one more question on this, that 10 ml of gaseous hydrocarbon was burned completely in 80 ml of oxygen. Again, we will write the equation first at all for one volume, and the volume of hydrocarbon is given as 10 ml. So this will be 10 ml, and this will be 10 bracket x plus y by 4 volume, this will be 10x volume, and this will be, we will not mention the volume of water because it is in liquid form. Now we have to decode the other information which is provided. The remaining gas occupied 70 ml. So remaining gas occupies 70 ml, which means that remaining gas contains oxygen which was in excess, and the CO2 which is formed. The volume of oxygen which was in excess and CO2 produced, it is equal to total volume, it is equal to the 70 ml as per the second line of this question. Now it is given that this volume becomes 50 ml on treatment with KOH. It means that if this volume is treated with KOH, now this volume becomes 50 ml. Obviously, KOH is the absorbent for the CO2. So 50 ml is the final volume, and 70 ml was earlier. So the volume of CO2 is volume absorbed by the KOH definitely, and definitely it will be equal to 70 minus 50, which will be equal to 20 ml, right? This will be the volume of CO2. Obviously the 50 ml oxygen will be present in this. 50 ml oxygen will be present in this because the entire CO2 has been absorbed by KOH. So we can find the volume of oxygen reacted. Volume of oxygen reacted, because we have taken 80 ml of oxygen and the unreacted oxygen present is 50 ml. So 80 minus 50, that will be equal to 30 ml. This will be the volume of oxygen which will be reacted. So now from this equation 1 and this equation 2, we can calculate the value of x and y. First at all, volume of CO2, which is 10x, which will be equal to 20 ml. So we can say that 10x will be equal to 20, so x will be equal to 2. Now the volume of oxygen reacted, that will be equal to 10 bracket x plus y by 4, and this will be equal to 30. This will be equal to 30. So on solving for y, we will get y equal to 4. So this will be the equation. So the formula of hydrocarbon will be equal to C2H4. Let's take one more example on the eudiometry. It is given that a mixture of formic acid and oxalic acid is heated in presence of H2SO4. The reactions has been provided like this. The produced gaseous mixture is collected and cooled. On its treatment with KOH solution, the volume of gaseous mixture decreases by 1/10. So first at all, we have to find the amount of gaseous which is present in gaseous mixture. So let's suppose if we are saying that formic acid, in the mixture of formic acid and oxalic acid, suppose if it contains A A mole and it contains B mole of oxalic acid. So very obvious, one volume, या फिर we can say that 1 mole of formic acid will give gaseous product COG. So for A mole, this will be A mole. 1 mole of oxalic acid gave CO2G and COG as a gaseous product, 1 mole of each. So for B mole CO2 and B mole of CO is produced. So total volume of gases, V gases total, definitely it will be equal to A mole. Yeah, we can say that we have to calculate the molar ratio, as we are dealing the problems in the identical condition of pressure and temperature. So molar ratio or volume ratio will be same. So the V gases total will be COA, A mole of CO, and B mole of CO2, and also B mole of CO. So this will be equal to A plus 2B. And it is given that on treatment with KOH, so obviously KOH is the absorbent for CO2. So we can say that VCO2, that will be equal to B, that will be equal to 1/10 of gases formed, that will be equal to A plus 2B. On solving this, we will get A ratio B, that will be in 8:1. Thank you very much.